Hello, welcome to the course of IPv6. So today we are going to discuss about the another kind of addresses that are associated in unicast addresses IPv6. So in this class, I will discuss about the 624 address, 6RD address, ISET TAP address and the Teredo addresses. So let's discuss about the first, that is 624 address. So here the 624 address is defined to make IPv6 devices on network communication possible over an IPv4 infrastructure. So if we are deploying the IPv6 devices over a IPv4 infrastructure, then then we have to use the 624 address to make the communication easier between the IPv4 and IPv6 address devices. So here the INA has permanently assigned a 13-bit TLA identifier for 624 operation within the global unicast address range. So here it defines the 16-bit TLA identifier. So here this TLA identifier having a value of 0 into 0002. So this is the value that is associated with the TLA identifier, which is defined by the INA in the global unicast address range of 001. So here the interface for 624 with an IPv4 address of, like here I have using a IPv4 address 62.2.84.115 and I want to convert it into hexadecimal and then the 624 prefix. So when we convert it into the hexadecimal notation, it will become a 624 prefix. So here the 62.2.84.115 address will become 624 prefix like 2002 colon 3E02 colon 5473 double colon /48. So this is the representation of the IPv4 address into the 624 prefix. So this is the 624 address format. Here the first 3 bit is represented as FP001. So this will give the representation of first bit which will be start with the 001 and it is representing the fixed prefix, and after that 13 bit will represent the TLA identifier having the value of 0 into 002 and 32 bit will represent public IPv4 address. So here the address which we are going to use must be a public, and 16 bits will represent a SLA ID and 64 bits represent interface ID. So the prefix has a total length of 48 bit and the IPv4 address in the prefix must be a public IPv4 address and it must be represented in a hexadecimal notation. So this is the representation of 624 address for space. Next we are going to discuss about the 6RD address. So here the 6RD is also known as the IPv6 rapid deployment that is published in 2010. So here the 6RD addresses will not have a specific prefix, means it doesn't represented by a particular prefix as the other addresses are represented. So it also don't have a fixed boundary, it means its length is variable. So the prefix total length is 64 bit and it will constitute of the ISP prefix and the site IPv4 address, and these two are of the variable length. So here the main difference in the address is that 6RD doesn't use a special prefix like 624 and it doesn't have a fixed boundary like the 624 address have a boundary of /48. So this is the 6RD address format. Here the ISP prefix will have a variable length, then site IPv4 address also have a variable length, and after that subnet ID also represent a variable length, but together this constitute a prefix length of 64 bit and last 64 bits are represented by the interface ID. Next part is the ISA-TAP addressing. So here the ISA-TAP addresses stands for intra-site automatic tunnel addressing protocol. So here the automatic tunneling mechanism is specified in RFC 5214. So these automatic tunneling mechanism is specified by the IETF in RFCs. So it is designed for dual stack devices that are separated by an IPv4 structure. It means here there are three network, like in first network there are the IPv6 addresses. In between the network, in between there are network residing that will have most of the devices with the IPv4 addresses, and after that the last network will also have a IPv6 addresses. So if the first network want to communicate with the third network, then it must go through the IPv4 addresses that is lying in between. Like if these IPv4 addresses are associated with the routers, so these routers must come in the route of these two network. So to pass this network of IPv4 addresses, there is a tunneling process. So these are designed for the dual stack nodes that will separate by a IPv4 structure. So the type identifier which will represent this address will have the value of 0 into FE, and type identifier specify an IPv6 address with an embedded IPv4 address. So here it treats the IPv4 network as one large link layer network, and it allows those dual stacks node or the devices to automatically tunnel between each other using any format of the IPv4 address. So for the short time they will use the IPv4 address format to pass that IPv4 network that is coming in between the communication of two IPv6 addresses network. So here there are the representation, like it will constitute of 64-bit, 32-bit. So let's discuss about these. So this is the format of this address ISATP. So this is the format, like 64-bit will represent the prefix, then 32 bits will have the two values. The first value is 00005EFE, and the another value is the 02005EFE, and the last 32 bit will represent the IPv4 address. So here this first 64 bit will have the same format as the global unicast address. It means that this the first bit that is represented as prefix must have a format that same as the global unicast address. Next 32 bit, as INA owns the IEEE organizationally unique identifier, that is OUI, so it specifies the EUI 48 format for this 32 bit. So here it is represented as 00005E. So from these 32 bit, 16 bit of type identifier will represent two values. The first one is for the private IPv4 address, the second one for the public IPv4 address. Like these 16 bits will represent that it is from the public IPv4 address or the private IPv4 address. So here if 0000 is represented, then this address is associated with the private IPv4 address, and if it is represented as 0200, then it is associated with the public IPv4 address. After that, the 8 bits represent the type identifier which indicates the IPv6 address within the embedded IPv4 address. So the value of type identifier is 0 into FE, and 32-bit, last 32-bit will represent embedded IPv4 address, and we have to represent it either in decimal notation or in the hexadecimal notation. So the example of the address I have given here is, like it is represented as 2001 colon db8 colon 510 colon 200 colon 0 FE colon 192.168.0.1. So the first is representing the, that is in the green color, representing the IPv6 address, and the last, that is in the yellow color, this address is represented as IPv4 address. So this is the format of the ISAT TAP address. Coming to the last, that is the Teredo address. So here the Teredo is designed to avail IPv6 connectivity to the devices that are present in one or the more the NAT networks. So here what happened, this is used to these Teredo addresses are used to give the IPv6 connectivity to the devices that are present in the NAT. So this is done by tunneling the IPv6 packet within the UDP. So here we will use the user datagram protocol, where we will tunnel the IPv6 packet with this protocol. So this method consists of Teredo client, server and relay. So here the Teredo relay are IPv6 router that are sitting between the Teredo service and the native IPv6 network. So these are the three devices that are in present in the Teredo address format, that is Teredo client, servers and relay. After that, this address format is of first 32-bit, that is the prefix. Next 32-bit represent the server IPv4 address. Next 16-bit represent flags, and the another 16 bits will represent port, and the last 64 bits will represent the client IPv4 address. So here we are using 32 bits for the server IPv4 address and 64 bits for the client IPv4 address. So let's discuss about the first 32 bit will represent the prefix length, that will be start with the 2001 colon 0000 colon and slash 32. Last 30, and then the another 32 bit that represent the IPv4 address of Teredo server. Then 16 bits will represent the type of address and the NAT in use. So the which kind of address we are using, like unicast, global, unicast, anycast or multicast. And next 16 bit will represent the port field contain the map UDP port of Teredo service on the client. So this will represent the UDP port in 16 bits. And last 64 bits will represent the client IPv4 address field contains the map IPv4 address of the client. So this is all about the Teredo addresses format. So this is all about the other kind of addresses in IPv6. Thank you.